Alrighty, everybody. I just got the okay to start our planetarium show, so I'm going to be putting away our space trivia questions because now we're going to be heading into the unknown. Ooh. And welcome, everybody, to the Morrison Planetarium. Really quickly, I just want to introduce myself. My name is Christian. I'm going to be your planetarium presenter. And just a heads up, folks, I'm not just a voice coming out of the walls, I'm actually a person, and I'm standing right behind you. Hey, how's it going, everybody? Don't, hey, nice to see you. Don't hurt your necks. Look forward into the dome before you. That's where the whole show's going to be. Everything that you see in purple is going to be one enormous screen, thanks to the help of 6 different projectors hiding throughout our planetarium dome. And I just want to let you know that I'm a real person and not a robot. And I'm going to be your space pilot in a sense because this show that we're going to be doing right now is different from all the other planetarium shows that we've done here in the Morrison. This one is called Tour of the Universe, and it's completely live, which means you're going to hear my voice for the next 30 minutes. And what this show is about, we're going to be starting off pretty close to the Earth, and we're going to be zooming all the way out to the very edge of the observable universe. Hopefully, by the end of this show, you won't have an existential crisis of where you are in space. You laugh now, but wait till you see how small we are in the grand scheme of things. So I gotta forewarn everybody, and hopefully it isn't cause too much dread. But before we get started with our show, I do have to go over some quick house rules just so that we're all on the same page and have an enjoyable time. There's a few of us in here. First off, there's no food or drinks allowed in. If you manage to bring any snacks, make sure those are put away till the end of the show. We want to keep the theater as clean as possible. We really do appreciate it, folks. And also, if you happen to have any cell phones, smartwatches, tablets, anything that produces really bright white light or loud sound, now's the time to put away those cell phones because they're really bright and they distract not only you, but the people sitting behind you. It really takes away from the planetarium experience. And folks, if you need to leave early during our show, you're more than welcome to do so. All we ask is that you exit at the very top of the planetarium. That's where you're going to find the exits before, during, and after the show. So when in doubt, always go up the stairs, not down them. Although if you're a person that has trouble climbing the stairs, don't worry. Once the show's wrapping up, just remain seated for a little bit longer. We'll have a staff member come by to escort you to a lower exit. So again, just stay seated for a little bit longer. And last but not least, folks, this show is very immersive thanks to our 75-foot dome above us. If at any point during the show you start to feel overwhelmed, you start to experience motion sensitivity, there's a really quick and easy trick to ground yourself. All you got to do is close your eyes, take a few big deep breaths, and your brain will remember that you're sitting in a planetarium in San Francisco and not hurtling across the universe, at least not more than the usual. Hee hee hee. But with that being said, we're just waiting for those last bit of cell phones to get put away. Looks like someone's checking their Instagram. And we're just waiting for that cell phone on the bottom left. If anybody's there, just let them know. Thank you so much, everybody. Well, with that being said, it looks like we're ready to begin our tour of the universe, and I invite y'all to sit back, relax, and gaze into the dome before you. Alrighty, everybody. As I mentioned, we're going to be starting off pretty close to the planet Earth, but we're starting at this spacecraft right in front of us. And we can see all the city lights start to pop up just down below, so we're not too far away from the Earth. But what's in front of us is something called the International Space Station, or the ISS for short. And a lot of people tend to ask me, hey, Christian, what is the International Space Station? I hear about it all the time in the news and articles, but I don't really know what it is. Could you explain it for us? Well, of course, folks. The International Space Station is a research facility, a laboratory that orbits around our planet Earth. And they conduct all different types of experiments up here that they're unable to do on the surface. The reason why there's less gravity up here, so they can test out a lot of other things they're unable to. And one of my some of the things that they'll experiment up here with are things like what happens when you try to grow plants in space. Do the plants grow the same? Do they grow differently with less gravity? What happens when you spark a match, a flame in space? Does the flame act the same? Does that act differently with less gravity? And one of my favorites is where they had 2 identical twins. One twin lived on Earth for about a year. The other one lived on the International Space Station for a year. After that year, they compare and contrasted. Turns out when you live in space for a long period of time, you tend to age a little bit slower. But not only that, you also lose a lot of muscle because you don't have gravity constantly working down on your muscles all the time. So if you plan to live in space for a long period of time, remember to exercise daily. And folks, the International Space Station looks really big here in our planetarium dome, but it's not that big in actuality. It's only about the size of an American football field. So if you've never been to an American football game, don't worry. You can also use the entire California Academy of Sciences, the museum we're sitting in right now. That's about how big it is. And also, what's even more impressive is that this thing is going incredibly fast. The International Space Station is traveling at a whopping 17,000 miles per hour, where it orbits once around the Earth every 90 minutes, and it experiences 16 sunrises and 16 sunsets a day. Whew, how romantic. And folks, the International Space Station looks far away from the Earth, but it's not that far either. It's only about 225 miles above the surface of our world. 225 miles, that's like going from San Francisco to Santa Barbara, a nice little road trip to get away with the family for the weekend. So not too bad. And to tell you the truth, folks, this is as far as we put humans out into space nowadays, only 225 miles above the surface of our world. The reason why, it's because it's very expensive to travel in space. You got to build yourself a rocket ship or buy yourself one, and then you have to get your hands on a lot of rocket fuel. So much rocket fuel, you got to escape the Earth's gravity. And then once you get all that rocket fuel, you have to account for all the food, water, all the air you're going to be breathing while you're up here in space, and that gets quite costly quite rapidly. But folks, the International Space Station is just the first stop on our tour of the universe. So now we're going to see it slowly disappear to the city lights down below. And before we lose track of it, I want to add a nice little orbital path so we can see it as it slowly disappears. Alrighty, everybody. Now we're looking down at our entire planet Earth. And I want to let you know that the space program that I'm using here right now is something that you can go home and download and you can fly through space just like how I am. The space program that I'm using is something called OpenSpace. So if you go to your favorite search engine, type in OpenSpace project, you can find the link where you can download this and you can fly through space. And it's a whole lot of fun. But just a heads up, this program is in its beta phase, which means that it's not completely finished. We may come across a few bugs and glitches. If we do, I'll point them out. Hopefully we can look past them. And also, this program uses a whole lot of processing power. So if you have an older computer, I wouldn't recommend downloading it. It may overwhelm that computer. But if you got something newer or a gaming computer, give it a try. It's a whole lot of fun. And also, we also have another great alternative if you don't want to download anything. The other alternative is called NASA's Eyes. So go to your favorite search engine, type in NASA's Eyes, like the human eyeball, and you don't have to download anything. You can just fly through space, and it's a whole lot of fun. But now that we got a sense of what we're using in here, let's leave our planet Earth and make our way over to our nearest natural neighbor to us in space, the moon. Now, we humans have been to the moon before, but that was a little while ago. That was between 1969 and 1972, thanks to NASA's 6 Apollo missions that brought a total of 12 incredibly lucky guys to walk on the surface of the moon. They conduct science, and of course, they had some fun. They got to play some golf up here as well. And luckily, we're inside of a planetarium, so I have some special powers. I'm going to turn off the nighttime on the moon. Hey, there we go. That looks much more familiar. Good to see you, moon. And again, last time we sent humans to the moon was 1972, a little more than 50 years ago or so. But don't worry, folks. NASA has a new space mission in the works that's going to be sending humans to the moon in the next few years. This new mission is called Artemis. And with Artemis, NASA wants to send humans to Mars. But before we send humans deep into our solar system, we got to figure out exactly how we're going to live out here in space. So the moon is the perfect stepping stone to figuring out the logistics of how we're going to be doing that. And what's even cooler is that NASA is going to be sending the first woman to the moon. But not only that, they're also going to be sending the first person of color to the moon. But not only that, they're also going to have lunar bases throughout the moon. Pretty much, our technology has greatly improved in the last 50 years, so we're able to conduct a lot more science in a much more compactable way. And one place where we want to set up a base is the south pole of the moon, because we found ice there, and ice could be very helpful for setting up lunar bases. And maybe we want to go set up lunar bases at other areas around the moon that we find of interest. Maybe we want to go to the deepest part on the far side in Aiken Basin crater. Maybe we want to go look at some collapsed lava tubes we weren't able to check out 50 years ago. But again, we humans should be heading back to the moon in the next few years. So look out for any news about Artemis. And folks, here on Earth, when we look up at the moon, sometimes the moon feels really close to us. Feels like you can reach out your arms and touch it. But the moon is incredibly far away. It's about 240,000 miles away from the Earth. Whew! 240,000 miles. Some of the adults in this room may have a car with that many miles on it. And if you take better care of your car than I do, you can even imagine driving to the moon if you drove for about 4 months nonstop, going about 80 miles per hour. Although I wouldn't recommend it. The roads out here are poorly maintained. Hee hee hee. And from here on out, folks, we're going to need to use a more useful measuring stick because at this scale, using miles is kind of like using inches to describe the distances between cities because space is so big. So astronomers use a more convenient measurement known as light speed. And light travels at a mind-boggling speed of 187,000 miles per second. That's roughly about 300,000 kilometers per second. So while it took the astronauts more than 3 days to reach the moon, traveling faster and farther than any human has done so or since, it only takes light 1.5 seconds to cross that distance at the speed of light. That's kind of like a short pause in conversation. But at last, folks, it's time for us to leave the moon behind. So everybody say, bye-bye, moon. We'll see you later. So cute. And now, folks, we're going to see the moon and the Earth as they start to slowly disappear. In fact, before we lose track of the moon and the Earth, I want to add some nice little orbital paths so we can see where everything is. And also, folks, on our journey, we're going to be traveling much faster than the speed of the human imagination. We're going to be traveling much faster than the speed of light. We're going to be traveling at the speed of the human imagination, thanks to computer models like OpenSpace showing us the most accurate images and information available to us. In any moment, the nearest star to us, the sun, should be coming into view. So here comes the sun. Do. And folks, the sun is also incredibly far away from the Earth. So again, we're the third rock from the sun. So 1, 2, 3, that's us right over here. Between us and the sun, there's about 93 million miles. 93 million miles. Whew, that's a good distance away. But in terms of the speed of light, that's not far at all. In order for sunlight to travel that distance, it only takes sunlight about 8.5 minutes at the speed of light. 8.5, that's not too bad. But now that we have a nice bird's eye perspective of our solar system, let's get a quick refresher. Right in the middle of our solar system, we have our star, the sun. The closest planet to the sun, we've got Mercury. Then we have Venus, and then Earth, that's us, and then Mars. These are the rocky terrestrial planets. These are places where we can actually land a spacecraft on. And then past the orbit of Mars, we have this really cool thing called the asteroid belts. And this is what it would look like if I highlight all the asteroids in our asteroid belts. There is a lot of them. There they are. So those are all the asteroids. And then past the asteroid belt, we have the really big planets. We have the gas giants, the Jovians. We've got Jupiter, the biggest of them all. Saturn right over here, famous for its rings. And then we have our icy gas giants. We got Uranus, the funny one, and Neptune. And of course, we can always add everyone's favorite and lovable dwarf planet, Pluto. So here's the orbit of Pluto, right on the bottom right-hand side of the screen. And a lot of people don't realize that Pluto hangs out here in this outer part of our solar system called the Kuiper Belt. And you're probably wondering, what's the Kuiper Belt? I've never heard of that before. Well, folks, the Kuiper Belt's going to be all this stuff. Yeah, whoa, there's a lot of stuff out here. So the Kuiper Belt is essentially a second asteroid belt. What you're mostly going to find out here are icy asteroids and short period comets that don't stray too far away. They have a nice short trajectory. And pretty much we came across the Kuiper Belt in 2006. The reason why is because our technology has greatly improved. As our technology gets better, we're able to spot much smaller, much further away objects. And that's the really cool thing about science, because as our technology gets better, we're able to observe things much further away and much smaller. So we get to rewrite the stuff that we already know. So again, we now have the Kuiper Belt, which is all the way out here in the outer part of our solar system, and who knows what we'll find in much further out in our own backyard as our technology gets better. But I'm going to put away the Kuiper Belt because that's just a whole lot to look at. And now, folks, I'm going to be adding on screen some of the many different spacecrafts we sent out in the 1970s to explore our solar system. So now on screen, we have the trajectories of Pioneer 10, Pioneer 11, Voyager 1, and Voyager 2, and the latest of them all, New Horizons, which did a quick flyby of Pluto in 2015. As we fly by, you can see that interaction. Pluto, the last line right over there. And just to let you know, all these spacecrafts are traveling fast enough to escape the sun's gravity and leave our solar system behind. But even the most distant of these robot adventurers, Voyager 1, has not traveled as far as light travels in a single day. In order for sunlight to travel all the way out to the orbit of Pluto, it takes sunlight about 5 hours at the speed of light. 5 hours, not too bad either. But folks, let's leave our planetary scale behind us because now we're going to be heading into interstellar space, the space between the stars. Distance now becomes so immense, it's going to take us about 4 years at the speed of light just to reach the next star system to us. Whew, 4 years. Alrighty, folks. So the closest star system to us, again, is Alpha Centauri, which is going to be this one right over here on the bottom right-hand side. You can kind of see it moving along with us. And again, 4 years at the speed of light just to reach the next star system to us. But 4 years doesn't really tell you how long it would take us humans to travel that far. Well, folks, if you're to get in a rocket ship today, left planet Earth, make your way over to Alpha Centauri, it's going to take you about 8,500 years to cross that distance. Whew, and that's just a one-way trip. But folks, let's stop and consider whether humanity has made its presence known beyond our solar system, because now we're going to be stepping inside something called the radiosphere. And again, we're now inside something called the radiosphere, and this represents the current limits of the most distant radio signals humanity has ever broadcasted, or rather leaked into space. And it extends about 90 light years in all directions, emitting out from the Earth. This first began in the early 1930s with strong radio waves, early television, radar signal, and then later the detonation of atomic weapons. All this stuff is emitting electromagnetic radiation strong enough to escape the Earth's ionosphere. And humans were broadcasting well before that, but the earliest radio was not quite powerful enough to escape the Earth. And since all these signals are electromagnetic, they are traveling at the speed of light, so this is kind of like humanity's electromagnetic footprint in the universe. And of course, the radiosphere is always expanding at the rate of 1 light year per year. So is anybody out there listening? And right now, folks, I'm going to be adding some markers on the screen. These many markers indicate the many thousands of stars astronomers have discovered over the last 30 years, which has at least one or more planets orbiting around them. We call these planets exoplanets, and we're looking for any of them that are Earth-like with conditions suitable for life as we know it. So far today, we found 5,000 confirmed exoplanets just in the nearby vicinity to us. 5,000 other worlds besides our own. Whew, that's a lot. And that 5,000 number is going to be increasing as the years continue because we have space telescopes where their whole purpose is to find as many exoplanets as possible. In fact, you can see on the left-hand side of the screen that we pointed our space telescopes just in this section of the night sky, and they found a whole heap of exoplanets just in that one direction. So as they continue to scan more and more of the night sky, they're going to be finding exoplanets left and right. Now, to say if any of them are Earth-like with conditions suitable for life as we know it, well, we cannot answer that question quite yet. Pretty much new space telescopes are being developed right now, so they're on the drawing board. It's going to be a few years before they're constructed and then launched into space. So we've got a little while before we can answer that question head on. But the more important point here is that quite a few of these planetary systems are within that 90 light-year limit of our radiosphere and could have potentially received our signals. However, since radio waves travel at the speed of light, if there is anybody that's out there able to listen in and answer back, the communication delays between hellos could be decades in time. Now, to give you an example, let's say we live in the left side of our radiosphere. Let's say this star system on the left. We find an alien civilization somewhere towards the middle on the right-hand side. We shoot them a text message. We say, hey, we live here. Takes 60 years to get to them. They listen in, answer back another 60 years. That is a 120-year conversation in the making. Whew. And I can barely wait for a text message from my friend. But of course, folks, planetary systems beyond the radiosphere, more than 90 light years away, have not heard from us yet, but eventually they will, as the radiosphere is always growing, but it becomes weaker as it does. And for now, I'm going to be putting away the exoplanet markers, and I'm going to leave our radiosphere up on screen, because as huge as humanity's electromagnetic footprint is, it is nothing compared to our Milky Way galaxy. Alrighty, everybody, we're now looking down at our Milky Way galaxy, and I've got to ask everybody, can anybody see their house from here? Just kidding. We're way too far away. And I want to let you know that our Milky Way is incredibly large, folks. If you wanted to cross it from one side to the other, it's going to take you about 130,000 years at the speed of light. Whew, that is big. And not only that, our Milky Way galaxy is so huge, we estimate that there's at least 300 billion stars in our galaxy alone. If our recent discovery of so many exoplanets just within our small neighborhood within this vast star city is any indication, there could be billions of planets and potentially millions of Earth-like planets throughout our single galaxy. And before we leave the Milky Way galaxy, I want to show you what it looks like from a sideways perspective. You're going to notice that we live in a big, flat, spiral disk, kind of like a big pancake. And when you look up in the night sky here on Earth, you probably heard someone say, hey, look, you can see the Milky Way from here. What they're referring to is this, the plane of the Milky Way galaxy. That's what you see up in the night sky. And this is important because when astronomers and scientists want to learn about the universe, it's so much more easier for them to point their telescopes galactically north and galactically south, instead of looking through the plane of the Milky Way, which has planets, stars, gas, debris, things that block their view of the universe. So just keep that in mind. We like to point our telescopes galactically north and south. But folks, the Milky Way galaxy is only one of many hundreds of billions of galaxies that comprise the known universe. So in this giant leap, every single point of light that you're now going to see no longer represents a star, but rather the location of an individual galaxy. Each galaxy containing hundreds of billions, perhaps trillions of stars. And we live in a local galaxy group which contains about 30 galaxies, large and small. Also includes the nearest large spiral to us, the Andromeda Galaxy, only 2 million light years away, just next door and heading right for us. We're going to get to know it pretty intimately in about 5 billion years, so mark your calendars. And as we continue zooming out, folks, you're now going to realize that galaxies are not evenly distributed throughout space. Instead, galaxies like to clump together in large groups and clusters, or they like to avoid each other where there's very few galaxies or no galaxies at all. So we can see a nice galaxy cluster towards the bottom over there. We can see very few galaxies towards the top of the dome and no galaxies at all. You can kind of think of galaxies like people. They like to hang out together or they like to avoid each other. And folks, since we're all the way out here in this outer part of our out here looking at these galaxies, I want to show you the latest image that was released from the James Webb Space Telescope. And right here, this photo is called the James Webb Deep Field Image. And folks, it is spectacular to look at because this picture that we're looking at occupies a really small portion of the night sky. If you were to pick up a sand grain off the floor, lift it arm's length up into the night sky, that's about how big of a picture that you're looking at in the night. So about the size of a small sand grain. And we're seeing hundreds of galaxies all in this one photo. And what's even more impressive is that you're seeing a galaxy cluster right in the middle, these really bright ones in the center. These galaxy clusters are so massive that they're causing space and time to warp, which is causing this bubble-looking effect. If you look towards the middle, you can kind of see like a bubble shape. And this is what we call gravitational lensing, because the galaxies in the background are being warped and distorted and duplicated. So we can see some galaxy distortion towards a little bit towards the bottom right here. We can see a nice one towards the top right. That's a good galaxy distortion. And what's even more impressive is that this picture that you're looking at only took 12 and a half hours to produce by the brand new space telescope, the James Webb, compared to the Hubble Deep Field image, which took 21 days to make the Hubble Deep Field image. So Our technology is improving, and I cannot wait to see what other images that the Space Telescope will be releasing. But let's make our way back to our show. And folks, this picture that we're looking at of all these galaxies right in front of us is represents the closest 30,000 galaxies to us in space over 300 million light years across. We got to give thanks to an amazing astronomer by the name of Dr. Brent Tolley, who him and his team worked over decades of time to compile this amazing representation of galaxies. So big shout out to Dr. Brent Tolley. But folks, now we have automated systems that are mapping even the most distant galaxies. And just to let you know, folks, we're about to see the very large scale structure of the universe. And remember, folks, every single point of light that you're seeing no longer represents a star. That's an individual galaxy. Whew, I feel small. And also, just to let you know, the shape of the large-scale structure of the universe is not in the shape of a butterfly or a bow tie. Remember when I mentioned that we live in a flat spiral disk of the Milky Way galaxy? Well, if we were to line up our Milky Way galaxy, it would line up just like so, right down the middle. And again, we like to point our telescopes galactically north and galactically south. But astronomers still want to make sure that there was galaxies through the plane of our Milky Way, which are these purple galaxies right over here. You're going to notice that we're still able to find galaxies, just not as many and not as far. Pretty much we have to wait for our technology to improve in order for all this dark stuff to be filled in, so it's just a matter of time. But folks, it looks like we're running drastically low on our tour of the universe. 30 minutes is just not enough time. So let's continue pressing on, because now we're going to be encountering these really distant, faraway objects known as the quasars. And the quasars are going to be these orange dots at the very edge of the large-scale structure of the universe. We got some quasars on the right, quasars on the left. And quasars are short for quasi-stellar radio sources. And these blazing objects are all billions of light years away. So now we're looking so far back in the depth of time and space that the most distant quasars represent the universe at a much earlier age. We're nearing the very beginning of galaxy formation. In other words, with the quasars, we're viewing a sort of awkward, gawky teenage version of the universe, and before there was a teenager, there was a baby. So let's press back to a time before quasars, planets, stars, and even galaxies began to form. Folks, we're about to see the very edge of the observable universe. Alrighty, everybody, here we are at the very edge of the observable universe, and what we're looking at is something called the Cosmic Microwave Background Image, or the CMB image for short. And all evidence indicates that the universe we live in is about 13.8 billion years old. This is data compiled by Planck and other radio telescopes. And the picture that we're looking at is a very baby version of the universe, only 380,000 years after the Big Bang occurred, where space and time began. And what we're looking at is not a typical photo either. Instead, this is a temperature density image where the light echoes of the Big Bang are color-coded, where the lighter areas correspond to the hottest, least dense regions, and the darker areas the coolest, densest regions. These fluctuations in temperature and density are extremely tiny. They vary no more than 1 part per 100,000. But these really tiny differences eventually gave rise to a large-scale structure of the universe that we saw moments ago, that clumping and clustering of galaxies everywhere. Figuring out just how that happened is one of the larger challenges for cosmological research today. Though our view here is of the outer edge of the known universe, folks, the earliest light visible to us, that radiation actually persists all around us. It permeates the universe, stretching and cooling as the universe expands over billions of years of time. But folks, we've traveled as far back as the law of physics can physically allow us to go, so we only have one direction left to go, and that's going to be back towards planet Earth. That's home. So let's find a nice entry point through all these quasars and galaxies. This looks like a good spot. And let's make our return trip back to planet Earth, y'all. Alrighty, everybody, we are crossing an expanse of over 13 billion light years, and we present you with this view of our universe and the latest in cosmological and astronomical information. We're covering eons and observing objects billions of light years apart. And we live in a golden age of astronomy with new generations of telescopes and spacecrafts that are extending the reaches of our eyes, preparing for the eventual race between the advancement of technology and the accelerating expansion of the universe. And with that thought, I want to remind you all that astronomy is for everyone. You don't need to be a rocket scientist to enjoy the beauties and wonders that our universe. All you need is the night sky, and if you can, get away from the lights of our cities and look up. Even a good pair of binoculars makes for a decent first telescope, and there's astronomy clubs all around the world that invite people just like you to look through their telescopes and peer into the great beyond, allowing you to partake in the wonders that our universe has to offer. Now, astronomy as a hobby can offer an endless supply of satisfaction, and I do hope you'll join us, those who dream amongst the stars. But it looks like we just made our way through our radiosphere. We're heading straight for our solar system. And now we're about to pass the space robots that we sent out in the 1970s. And we're about to pass the orbit of Pluto and the Kuiper Belt. And we're making our way to the third rock from the sun, our homeworld, planet Earth. And just to remind you folks, all the humans that you know today and all the people that's ever existed in history all lived on this one planet that we call home. And it looks like we're about to pass the orbit of the moon, the furthest we've ever sent humans out into outer space. And as we make our final approach back to planet Earth, folks, this is going to be the end of our Tour of the Universe show. And I want to thank y'all for stopping by and watching it with me today. I hope you did enjoy it. But hey, look at that. We made it back home safe and sound. And that's all for now, folks. Thanks for stopping by.